All right, this is lecture problem number 1 in chapter 7, first order differentials. And what I've got set up is the time t less than 0, and basically the quantities for the currents through the different components is at t much greater than, or t equal to 0. And at that point, we've reached a steady state in DC. So let's see what's going on here, and we can actually see the currents up above in our current readings. We have 9 volts on this side of the switch and 9 volts on this side. It's basically just a short circuit, so you would clearly expect that. In order to get 9 volts at this point, the 2 milliamp source is giving us 1.5 through the 6K. That gives us 9 volts here. That means that half of a milliamp is coming across the switch. It joins up with the 1 milliamp coming through the 9 volt supply and goes down through the 1.5, or goes down through the 6K resistor. Because we are at steady state, there's 0 amps coming through the capacitor. Now at this point, let's open up the circuit to get the transient to occur. And again, our transient, the time frame tau is 15 milliseconds, so the transition should be complete, or very close to complete, at 5 tau, which is 75 milliseconds. So we can see the transient taking place here. I'm going to stop the circuit just a minute so that we can investigate a little bit further. Now the current through the capacitor is not registered as 0, but it's very, very close. We can see the green line here, and it's very close to 0 amps. For the current through the switch, of course, we'd expect it to be 0 since it's been thrown open. Now what's interesting about this circuit now is that the left hand side is operating independently of the right hand side, and at time t greater than 5 tau we actually have the capacitor equal to 0. So this is a circuit in and of itself. And we can see that when we turn the simulation on. We can see that the current is just rotating through here and then rotating through the right hand side. So we have two independent sections of the circuit as operation goes, and there's 0 current coming through the capacitor.